In this exercise we are going to georeference a scanned map. We will use this georeferenced map as a backdrop to digitize vectors, that is points, lines and polygons. You can find the course data at our OpenCourseWare website ocw.un-ihe.org. It's the data from exercise 1. Depending on your browser, you can save it to your hard disk. We'll put it in the folder of exercise 1. It automatically saves it there now. And we can find it in the folder. And we're going to inspect it because it's just a JPEG, it's not a GIS file format. So depending on your computer, it opens in your picture viewer. And we can have a look around what it mentions, and we see already a very nice grid on top of the map. Mount Marcy, New York, Essex County. We see coordinates in degrees, we see something in meters. We see also that it increases to the right, and we also see a projection in feet. Now normally there's some extra information printed on the map, so it's always good to read and interpret that information. So here we find projection and 1000 meter grid, zone 18, universal transfer Mercator, and 1927 North American datum. Now we can go to spatialreference.org to find the EPSG code. Remember that EPSG codes are a standardization of projections in a number. So UTM for universal transverse Mercator, zone 18 N for north, so these are the keywords, and NAD27 as a datum. And we here find the code 26718. You can check that it's in the right location, yeah, North America. And we copy this to the memory because later we need it to define the projection. Okay, let's go to QGIS. For georeferencing we need a plugin. It's called the Georeferencer GDAL plugin. It's an interface to GDAL. It's a core plugin, so it's already installed. You just need to activate it by checking the box. And then we find the tool under the raster menu. The Georeferencer tool is opened in a new window. It's best to maximize this. Now we can open the JPEG that we are going to georeference. There it is, and when we want to load it, it asks for the coordinate reference system. Since it doesn't have one, we have to press cancel. That's very important, so it uses only the values from the JPEG itself. Now we can set the transformation settings in this dialog. First we have to set the transformation type. A linear transformation is the most simple one. It's a rotation and a scaling of the image based on our ground control points or GCPs. If that doesn't result in a high accuracy, we can increase to a higher order transformation such as a polynomial first order or second order. So here we first start with a linear transformation type. Now we have to set the resampling method. The nearest neighbor method will preserve the pure pixel values as much as possible, while the cubic convolution method will take an average of surrounding pixels. In this case we want to use the map as a backdrop, therefore we need a smooth image and we don't need the pure pixel values. Therefore we choose here the cubic resampling method. Obviously we also need to define the target projection. So here we can choose by pressing this button with the EPSG code that we have copied the right projection UTM zone 18 north on the datum NAD27. This will be the target projection after georeferencing. Now we choose the output file name. You'll see here it goes to the right folder. And if we keep it checked to load in QGIS when done, the result will be loaded in the map canvas. So now let's collect our ground control points or GCPs at the nodes of the grid. So with this button we can add a GCP. It asks us to give the coordinates, which we read from the site. So first the easting, 581,000 meters east, and the northing, that's 4,885,000 meters north. And we see that the GCP is placed in the table below. We see the file coordinates and then the destination coordinates in UTM. Let's go to the second point. The minimum is about 4 points, which should be well spread over the map. The more points, the more accurate it will be. So we place here our second point. I place it on purpose a bit off the node to show you later how to move it. So I'll read the coordinates from the site. So that's 599,000 meters east. You see they omit the zeros, and 4,885,000 north. The red line shows the error, which is very large, but we only have 2 points, so it cannot really determine it. With this button we can move the GCP to the right position if we haven't clicked it immediately at the right position. Let's place a third point. Let's take a nice spot. This one is clearer than the others. Let's add the GCP. Read it from the site. So that's 600,000 if we extrapolate. Easting, and now the northing, 4,873,000 meters north. Now we'll do a fourth point. Place the last GCP. And we'll read the coordinates from the sites. So that's 581,000 meters east and 4,873,000 meters north. Okay, now we have 4 points, and the red line gives us the error in pixels. It's displayed here in the table, and we also get it in the status. So we're about 41 pixels wrong, which is quite a lot. So the solution can be to remove points and add other points, or to use a higher order transformation. So let's go to a polynomial first order transformation and see what happens. And we see that the error is drastically reduced. The number of pixels, when we zoom in, we see the error is within 1 pixel, and the mean error is 0.2 pixels. So that's acceptable. What is acceptable depends on your purpose. And when I press the play button, it does the transformation. And the output will be shown in the map canvas. So I can remove this window for the georeferencing. I don't need to save the GCPs, it has been okay. And we see that the projection of the map canvas has been changed also to EPSG 26718. And we see that the map is here. Now we can verify the coordinates in a very simple way using the coordinate capture tool. There's that button, and then let's just sample a coordinate. So we have to click Start Capture, and then we click on a pixel, it will report in latitude, longitude, that's in the first field, and in the UTM coordinates in the second field. And if we read it from the sides, we can see that the value that we get, the X and the Y, are pretty close. So that confirms that the reprojection was quite successful. Let's take another point. And also there, when we read the coordinates from the sides, it's pretty close. So that's one way to confirm. What we can also do is use a background map that is already georeferenced. So if we use the Quick Map Services plugin, we get access to a lot of internet resources, base maps, such as Google and OpenStreetMap. And under the web menu, we can find then the Quick Map Services. And if we go to settings the first time when you install it and more services, you can get the contributed pack. And with that you can get a list as big as the one that I show here. And let's load here the Google satellite image in the background. And let's see how good our map fits with the background. Well, we can do it by toggling. If we zoom into a lake, we can check if when we toggle on and off if it has a good fit. But as you can expect, there are also better methods. If we press F7, we get the layer styling panel, and there we can set the transparency. We see it changes live. That's a way of verifying. But the better way is to use the blending mode and put it to multiply. This will blend the two different layers. So here we can check now how good the shores of the lake fit with the satellite image. There could be a time difference between acquisition of both, but we see that this is reasonably nice. So the georeferencing compared to the satellite image has been very nice. We can also blend it with another layer like the OpenStreetMap. And there also we don't see any difference, which means that it has been done very well. A bit of toggling, we can see that the dam even is in the right position there. So now this means that we are quite confident that this scanned map, which is now georeferenced, is a good backdrop for digitizing. So we are going to create a GeoPackage with points, lines and polygons. We'll first start to create a layer with points, with all the peaks. So we go to the layer menu, choose create layer and new GeoPackage layer. Because this is the first layer that we create, we also need to create the database, the GeoPackage database. So let's call it Mount Marcy. And then the name of the table. In this case there will be peaks because it will contain the mountaintops. It has a geometry, the point geometry. We will not use the Z dimension, we will just directly use the values for elevation. And we check that the right projection is chosen, which is the case. And we add an attribute with the name elevation, which can be a decimal number, a real number. And then we can add it to the list of attributes. By default there will be an ID number and then the attributes that we add, so we can also add other ones with text data or date and time. If we want to, for example, add the name of the mountain peak, we add text. So we see the peaks layer is added. When we hover our mouse over it, we see the location in the GeoPackage, and we can toggle editing. And then we can add the points. So here's our first point. It auto-generates the feature ID, so we only have to fill in the attribute for elevation. So that's 764 meters. And let's look for another point. Here we have another point, so we add another point. Auto generates the feature ID and we have to only type 738 meters. And let's take a third one. If you use space in editing mode, we can pan by just dragging the mouse. Here's a third point. Again, it auto generates feature ID and we type 1066 meters. So these are 3 elevation points. And what we can do is we can save it, or we can still edit it by moving the vertices. Here it's highlighted and then we can move it, or we select it and move it back. And there's undo buttons and we can save. Once it's saved, it's stored in the attribute table. And let's open the attribute table, and there we see our 3 elevation points with auto-generated feature IDs. So our first layer in the GeoPackage, our point layer, is ready. Let's create a new one. We select the same database and we create a new table. That will be the one of the rivers, so we call it rivers or river. And it's a line, projection is the same. Name is the name of the river, so we call it name. In this case it's text. And we limit the length to 100 characters. And then we add it to the field list. Again, automatically feature ID will be created and this will be added. Now this layer is a new layer, so we choose add layer to the database. When we hover our mouse, we can see the information of the layer in the database. Let's choose a nice river for digitizing. So here we have the slide brook. We toggle editing. And we start from the upstream to downstream, because with lines also the direction is important. So with this button we can add nodes for the line. And we trace the river from the backdrop towards the downstream. Here you clearly see the effect of the resolution. We approximate. If you make a mistake, you can press backspace, it goes one node back. With every left click you add a node. Now we're almost at the point where a tributary joins. We place a node there because we need it later if we want to add the tributaries. In that way the tributary will be accurately joined to the other river at the right spot. I'll stop here. If you click right, it will finalize this feature. The FID will be automatically generated, and with the name we type slide brook. Press OK and we see the thin line which has a random color. In this case it's not very visible. Later we will style it. And let's do the tributary. Again we start from the upstream and we go to the downstream. First of all we need to activate the snapping toolbar and set the snapping, because we want really that the tributary snaps to the vertex that we have placed. We can change it from pixels to meters, and we put it, for example, at 25 meters. That's the tolerance. If we are within that distance, We can test it here if we zoom to the junction. If I come close within 25 meters, it will highlight and we will snap lines that we digitize to that point. So let's start digitizing, tracing the river from the upstream to the downstream until we hit the tributary, where the tributary enters the other river. There we go. We see that the other tributary joins there, so we place a node exactly at the point where we want to snap the other one. And we see if we come closer that it will snap to the dot, to the vertex, click right to finish it, and then we type Slidebrook again, because this is still the Slidebrook. And let's do the last one. Similar way, upstream to the downstream, and try to connect or snap to the vertex that we placed at the junction. So again, when we come within 25 meters, it will snap, we click there, and we finalize it by clicking right. And we also call it Slidebrook. Okay. So we save it. If you do discard, it means undo everything that you did. So that's in emergencies. And let's open the attribute table, and we see here 3 feature IDs and 3 times Slidebrook. Now if we want to consider the Slidebrook as 1, we need to use the dissolve function, which is a vector geoprocessing tool. So there we go, dissolve. We choose the rivers layer and we click these 3 dots on the side, unique ID fields, and we check the box at name. Then it will join every feature with the same name. In our case, every feature with Slidebrook will be joined into one. And we add this to our GeoPackage that we already have. So we have all the layers together. And it asks for a layer name. So this is rivers, but then dissolved. Okay. And then I run it. And it's quickly done. Now let's check the result from the attribute table, and we see indeed that now there is only one feature. And when I select the feature, I see the whole river, including all the tributaries, becoming yellow. So that means that it worked. So let's rename the layer to something that makes more sense. So rivers dissolved. And let's remove the other one. Okay, and turn off the selection. Now let's do polygons. We're going to digitize the lakes. I choose some small ones, just for demonstration purposes. So again, the same procedure, layer, create layer, and then we choose a new GeoPackage layer. We choose the existing database of Montmorency. Change the table name to lakes, and for the geometry we will choose polygons. The projection is still the same, and here we also use the name of the lake, text data, 100 characters, add it to the fields list, to the attribute list. When we press OK, we click add new layer to add this layer also to the database. Toggle editing, and there we can trace the perimeter of the polygon. If we place the nodes too close by, it gives these warnings. That's not so problematic. So I can just continue. And when you want to place the last node, you click right and it will be connected to the first node to complete the polygon. FID is automatically generated, and the name, in this case we just make it Lake 1. Check in OpenStreetMap if there's a name of a lake. No, even there's no name of the lake. So let's keep it Lake 1. Now let's move to another lake. Zoom in well. And the same, we just trace. Remember, when we do backspace, we go one node back. When we toggle editing, we can select discard if we are not happy. That's a complete undo. There are also some undo and redo buttons that you can use. With space, we can pan. So when this one is completed, let's call it Lake 2. And let's also do a third one. And we give the original name Lake 3. Toggle editing, we save it. And now we also can check this attribute table. If you click right, open attribute table, and indeed we see the 3 polygons. Now let's toggle here to editing in the attribute table, and we are going to add a column. I want to add a column for the surface area. So surface area in square meters, which can be calculated using an internal geometry function, which I will show you. And that will be a decimal number. Click OK. We choose here surface as output equals and then the name of the function. Under geometry we find these functions. Area will calculate the area using the map units. And we see a preview. So surface equals $area. When I update it, I get here the surface area in square meters. In the same way, we can calculate for the rivers the lengths of segments, and we can also add coordinates already. But I can choose there categorized. And we choose the name column there. Choose classify, and now every lake will get a random color. A unique color per lake. For the rivers, let's give them a simple blue color. Do OK. Have to zoom to the layer, clicking right, see the whole layer there. And now nicely in blue. And we can also change the style of the peaks. We can use F7 to see the life changes. I choose there all symbols and give it a triangle, and let's make the triangle red. And we can also change the outline. Let's make it black, so we have red triangles with a black outline. Just some simple styling. We'll focus more on styling in another video. Now it would also be nice to have some labels. So let's label the peaks with the number of their elevation. And there we are. We see now the numbers printed next to the peaks. It's better to make them more visible, create a little bit bigger distance from the triangle. And we can use a text buffer so they're even clearer to read. And what we can also do, play a bit around with the labels. If we add things, we can concatenate text, so we add meters to it. And for the river, it would also be nice to have the name of the river next to the river. So we use also the label with the name. We see there in black Slidebrook next to the river. Let's change the positioning. Can make it curved. It's especially nice with rivers. It will follow the flow of the river. And there are all other kinds of options that we can set. So you can play around to see the effect. Change the font type and the color. Let's also make it blue. And there it is. This labeling is depending on the zoom level. So we see that it moves a bit. And if we remove the background layers, we see here our digitized points, lines and polygons. They're all stored now in the GeoPackage. You can also save the styles to the database. You can save it as a layer style or SLD, but we can save it also to the GeoPackage. You can give the style a name and a description. And we can check the box to use it as a default style for the layer. And it will be automatically added when we load the layer. And let's do the same for the rivers. You also save the style in the GeoPackage to have everything together. And that's of course a big difference with a shapefile. We can have now points, lines and polygons together in one file, the geodatabase, including the styling. And for peaks the same. And there it is. Now to prove that everything is stored in the database, I'm going to remove these 3 layers. And add them again. So in the browser I go to the right folder. And there I see the Mount Marcy GeoPackage. And I add the 3 layers that I want to use. Be sure to use the dissolved. And there it is, including the styling that we previously gave. So in this exercise we learned to georeference a scanned map and to use that as a backdrop for digitizing points, lines and polygons that are stored in a GeoPackage, including the styling.